forecasting. So we're not going to get tested. You're not going to get tested on this, so you don't need to do anything if you can just sit back and watch if you want. Chapter 11 of the textbook has a whole bunch of methods on this, and I'll try to tie this to the real world for you a little bit in the end. But let's build some forecasts first, and I'm going to show you some of the basic time series methods. For you guys, I sort of changed the order of things. Usually I cover regression, chapter 9 and chapter 11 together, and then I do chapter 10 after. In terms of chapter 10, that's the stuff we were doing yesterday. I'll just point out here, I've got quiz 5 materials here. I got quiz 5 materials here now. I have, and this is all new. I just created this morning. It was a little bit of an early morning. I got a practice quiz here, and the practice quiz for tomorrow is just looking at the R printout. So if you go through this, I think it's pretty easy, but you guys all just learned this recently, so maybe not. It's hard for me to gauge. Essentially, I did all the analysis, and if you open the spreadsheet for quiz 5, I'll just show you what's in there real quick since we're talking about it. And I'm going to try to make a second practice quiz, but I don't know if I'll have time. So I give you the data. Obviously, in the text document, I explain the data. I break it into training and test, right? So here's a certain number of observations. I split it into 2 groups like we did yesterday. All that's done for you. Here's all the R commands that I executed. And in this last tab is all the R results. So all you have to do is understand these R results and answer the questions, okay? So see if you can do that, right? I actually just wrote the answers for this while you guys were taking that other quiz. So the answers are also here. If I get a chance, I'll put a second practice quiz there. I hope I can get that done. You might see the second practice quiz, no answers. I'll try to get the answers by tomorrow morning for sure, so you can check things out, all right? Let me know, of course, if you have any struggles or whatever on that. So yeah, it's kind of like read it and understand it. That's it, okay? So you don't actually have to calculate, okay? All right, so for time series, pretty important topic if you're in the financial world, especially in the sort of, well, any kind of financial data. Any kind of data in time. So that's when we use it. So I'm going to start out with this hardware sales data, and I'm going to give you a quick overview, and then we'll do a few forecasts, and then and I'll show you how you would evaluate them.
Sorry, so which one was it again?
This is the hardware sales data. We're in day 8, part 1.
Right.
And then, like I said, we'll have break at 12:30. We'll resume at 2:30. I'm going to try to get back here at like 2:20 because we're having 3 guests in class at 2:30, maybe 4. One guy who might come is an undergraduate at AAU right now, and he might come, and then 3 other people are going to come. If you look at this data in time, right, if you do the line graph of this data, you will see that it shows neither trend nor neither one trend, nor does it show seasonality, right? It's sort of very idiosyncratic in its sales levels. So how can you forecast this, right? If you don't know, if you don't have any trend, you can't set up a time variable or something, and if you don't have any, we don't have any correlating variables, we don't have any X variables, we don't have any seasonality that's obvious, right? So how do you forecast this, all right? So that's the key here. That's what we're going to do. So there's 2 basic types of forecasts that people use, and they are moving average and exponential smoothing. So moving average is really easy forecasting method. Exponential smoothing, slightly trickier, but still pretty easy. So in moving average, you just look at the average of the last few periods. So the idea of these methods is we're going to use information that's in the Y's to predict the Y's, right? So if I'm doing a moving average for period T, I'm going to use the y from period t minus 1 and the y from period t minus 2 and the y from period t minus k. The notation here is a little annoying. T minus k. And I'm going to divide that by k because there's k y's in that list, right? So I'm going to look at the last k periods, where k is some number. K is like some number, right? And I'm going to take the average of those last k periods.
So why are we using k? Is that just for fun?
We could use n, but n is usually the whole data set size, right? So we're using k because it's just the difference.
Okay. Right.
So it's just sort of like my math pedigree or something. I don't have a good answer for you, right?
Yeah.
So for example, if you want to do MA, we'll call it an MA2, right? K equal 2. Can I help you find? Did you lose something?
No, just like that.
Oh. Yt equals yt minus 1 plus yt minus 2 divided by 2. Right? That's a moving average using the last two periods. All right? So we'll do that now. Let's do these forecasts. I'll take you a little ways down the street here, and then I'll show you what's possible. This is more like if you ever get into this, you can sort of understand what's going on. Then I'll show you a real-world application. So a moving average 2 forecast works like this. I need some data to get started, right? This is actual data. I need some data to get started, right? I can't do a forecast for period 1 because I don't know what happened in period 0 and period minus 1, right? So the first place I can make a forecast for is period 3. So I'll just do the average of the last 2 periods before period 3, right?
But you already know what period 3 is, so why are we estimating it?
Very good. So you're trying to decide, it's a very fair question, you're trying to decide which forecast, which number of periods is going to track the actual the best. And then you would use that forecast going forward. Okay? So basically we're trying to develop a new forecasted series that tracks the actuals as good as possible. And I'll get into how we measure the tracking in a second. Okay? So if we do this, right, very easy to do. I just made those forecasts all the way down, right?
So what did you average?
I averaged the first 2, right, to get to the third one, okay? And you can see that this average kind of moves over time, right? That's why it's called the moving average. In fact, I'll just graph this real quick to show you. Comes out real nice in the line plot, right? The blue is the sales, and the red is the moving average 2 forecast that we just made.
So it's just the average of all the numbers before it.
Right. So you notice it kind of lags behind a little bit, right? It looks like you took the blue and you moved it off, right? Another thing you're going to notice is as the number of periods K grows, the moving average forecast gets more smooth. So I'm going to do a couple more real quick. I'm going to do an MA4 and an MA8. So MA4 you can't start till MA4 you can't start till period 5, right? You need the first 4 observations.
So quick question. So in the MA2, it's not looking at all the previous Y's, it's looking at just the 2 previous.
Right. So so there's a hypothesis, Jake, that that your most recent data is the most valuable.
Yeah.
Okay.
Okay.
Right.
Just average.
Right.
This average is moving with the formula.
With with the time. So that's where it gets its name from, right? It's moving with the data, basically, right? So it's really a very near-term forecasting process too. Like you're going to forecast tomorrow based on what happened today, right? Until you find out what happened today, you can't actually make the forecast for tomorrow. So it's sort of an everyday kind of forecasting method. So here I did the MA8. By the way, this is a quick aside. You could also, instead of just doing the simple average, you could add weights to these. I don't generally cover that, but you could make the most recent observation with the highest weight, the next observation with a little bit lower weight, and so on, right? So that would be called weighted moving average, right? But you have to determine what those weights are, right? Here we're just taking the last however many periods and we're counting them all equal. All right? So if you graph what we got now, you'll see that as the number of periods grows, the forecast, it's sort of hard to see, and Excel doesn't pick maybe your favorite colors, but you can see that, for example, the purple, which is moving average 8, the purple is the most smooth one, right? The green is a little bit less smooth, and the red, in a way, is the most responsive. So one is sort of averaging out more, and the red is more responsive, right? Now, one thing is you might need a way to decide which of these three is the best, right? So in other words, figure out which K you like the most, right? So we need some measure of error. All right, so over here in some other columns, I'm going to leave a space for later. I'm going to calculate the errors. So I'll call it error MA2, and I'll copy that label to the right, so I'll do the error for 4 and the error for 8. There's several ways to compute the error, but essentially what we want to do in computing the error is we want to take the actual and see how far away it is from the forecast, right? We want to take the actual and see how far away it is from the forecast. I'm going to show you a really fast way to do this in a second, but we'll do it manually once, okay? So you can look at the absolute difference, or you could look at the squared difference, or you could look at the percentage difference. Those are generally the three ways that, and you might have done some of this a little bit in operations management, because sometimes the teacher covers this stuff. So sometimes they call it mean absolute error, or mean absolute deviation. Sometimes they call it mean squared error, and we call that in statistics. And then there's mean absolute percentage error or something, right? So these are all different errors that you can use. We're just going to use, I can't even think of what we should use. I generally use just one of them here. Let me cheat and check my answers here, because I'm going to give you all these things answers.
So we can just calculate variance between the estimate and the actual.
Yeah, it's basically the deviation. I just want to know, should we put abs? Yeah, let's do it that way. Let's calculate the deviation, right? So for this, I mean, the thing is we don't care if the deviation is positive or negative. We just want to know it's off. So I'm going to use abs formula. That's absolute value, right? And I'm going to take the actual, and what I'll do is, and I'm thinking ahead here, I'm going to anchor this in a very strange way. I'm going to anchor it only on column B, but not on row 6. And this is because I'm lazy and I don't want to type this in over and over and over, okay? So you'll see why this has a benefit in a second. And I'm going to subtract the forecast, right? And when I do that, it's just going to give me a positive number. How far off were we? And it looks like on that particular observation, we were off by what, 24?
Yep, 23.5.
23 and a half, it turns out. We're not showing decimals over there, so we can't see that. So I'll drag that one down. That's a list of errors for that first series. And then if you copy this formula carefully to row 8 in the spreadsheet, or week 5, right, it's going to calculate the error. Let's see if it worked. Yeah, so see what happened? Because of the way I anchored that, right, it's still using the actual sales, but now we're comparing the actual sales to the MA4 forecast. Okay, this is about where students start getting lost, so I'll slow down for 1 second. Right? These errors here correspond to the differences between these two rows. I'm going to make the next column correspond to the differences between these rows. And this one-way anchoring business is helpful so that I don't have to enter this formula over and over again. I'll double-click and move that down. And then I'll copy that formula finally here to row 9 for the MA8, and I'll double click there to calculate that. So you see how I did that. So I'm gonna do some summary measure of error, right? Because these errors are just the errors for each row. I'm gonna do some summary measures of error at the top. Now I could take the average of these absolute deviations, right? That's the mean absolute deviation. Or I could take the mean square error. I'm gonna do the mean square error. Okay, so these are gonna be on the top. So I'm gonna put a label right here, MSE, for mean square error. And the way I'll calculate this is, so it's a function in Excel, I think it's called sum square. Yeah, sum square. So you probably haven't used this formula before. We'll just do this all the way from the top to the bottom. So G4 to G107. So what that does, sum square, is that it takes every observation in the list and it squares it and adds it up, right? So 0 squared, 23.5 squared, 393.5 squared, and so on, and then it adds it up, right? So these are errors, right? Then you square them, they're squared errors, right? And then you add them all up, right? So you have a sum of squared errors, and now you want to take the mean, so you want to divide that by the count G4 to G107. And the good thing is we'll only have to enter this formula once. This is where count really comes in handy, right? Because you could just divide it by whatever, 104, but there's actually different numbers in the number of numbers in the lists. So. Okay, so mean square errors. They don't have too much meaning because they're in squared units. So last thing is root mean squared error. Right, this gets it back into the units that we're in, the sales units. So take the square root of the one below it, G1, oh sorry, G2. And what I'll do is I'll format these as the same. All right, so let me show you the formula.
Can you also use the variance function instead of sum square?
Yes, you might be able to. Trying to think what would be the variance function. Problem with the variance function, I don't think it's going to.
It calculates the mean and it's just.
Yeah, exactly. I don't think it's going to give you the same answer because the errors aren't necessarily mean zero. So between these three models, which one has the smallest error? Yeah, MA4. MA4 is the best. Now, you don't need to know this, but I'm going to insert one more row at the top. There is a formula that will give us the RMSE all in one step, I think, if I can remember it. Oh well, we don't need to know that. We're not going to do that. Forget it. I'm taking that row back out. All right, so that's moving average. We've calculated that the MA4 model works the best. There's another type of forecasting method called exponential smoothing. See, we're rapidly running out of time, so I will show you the formula. It's actually very similar to moving average, and I'll try to show you why. I actually have to check one thing in the book so I don't give you the wrong formula right off the bat because it's easy to forget. Chapter 11. Moving average, weighted moving average. Here we are, exponential smoothing. So the way I like to do this is next period's forecast, YT, we'll call it YT plus 1 here. I apologize for the change of notation. Next period's forecast is equal to alpha times this period's actual plus 1 minus alpha times this period's forecast. So you take basically a weighted average, right? And alpha is a number between 0 and 1. So you basically take a weighted average of what happened this period and what you forecasted for this period, and you weight them by some alpha that you choose to get next period's forecast.
And, can you just repeat again?
Yeah, so you see what happened, right? So you're giving some weight to what just happened in your next period's forecast, but you're also giving some weight to what your old forecast was. So this part might make you wonder, why are we doing that, right? Well, if you substitute in, right, it's alpha times yt. If you substitute in over here, you get 1 minus alpha times yt minus 1 plus 1 minus alpha times yt minus 1 half, right? Doing a little bit of algebra, I've got alpha times yt plus 1 minus alpha times yt minus 1 plus 1 minus alpha squared times yt minus 1 half. So if we look at this same forecast, take it through, it's really using some of what happened today, some of what happened yesterday, and yesterday's forecast, right? And basically we're giving the greatest weight to what happened today and a little bit lesser weight, because all these numbers are less than 1, to what happened yesterday. And if you keep extending this back, it's an exponential smoothing forecast is basically a weighted average of everything that happened in the past, but you're weighting things further in the past less and less and less and less. So it's like a weighted moving average, okay? This is all exponential smoothing. So while it looks like initially in this formula, right, it looks like you're just weighting today and today's forecast, today's actual and today's forecast, what you're actually doing is you're looking back infinitely, right, and weighting it. Okay, so it's just a different technique. Why don't we do one, and then we'll calculate the error of that, and then we'll stop. Again, I've got a big old spreadsheet with tons of these in it, but we'll just do one so you can see how it works. And then I'll show you an example online. Insert column. So I added column F. We'll do an exponential smoothing forecast with parameter alpha equal 0.2, okay? And actually, you guys are almost, well, you guys, not almost, you guys are smart enough now that you could actually determine the best alpha, okay? And I'll show you how you could do that. We won't do it, but I'll show you how you could do it. So that's just a label. I'm gonna need that 0.02, so I'm gonna put the 0.02 in a cell right above. Now the tricky thing about an exponential smoothing forecast is, for me to forecast period 1, right, I need to know what happened in period 0, right? But I don't have any period 0. So the first period I'm going to be able to forecast is period 2, and I'm going to need to know what happened in period 1, right? Because it uses 1 period back. Well, I have an actual for period 1, but I don't have any forecast for period 1. So how can I forecast period 2 if I don't have any forecast for period 1? So you need some way to get started, right? So we cheat. What we do for the forecast for period 1 is we say, make it equal to the actual. So we have to get on the ladder, basically, somehow. Okay, so that's all that is. All right, now we're going to make the forecast, right? So the forecast for period 2 is 20%, because we chose the alpha that way, 20% multiplied by, and I'm going to anchor this, by the way, because I'm going to copy it down in a minute, multiplied by the actual for period 1 plus 1 minus 20%. Again, make sure you anchor that puppy. Multiplied by the forecast for period 1, all right? So that formula right there I just entered is exactly this formula right here. The forecast for period 2 is alpha times the actual for period 1 plus 1 minus alpha times the forecast for period 1. All right? The good thing about the way we entered it, oops, what did I do wrong?
Comma and
Is there a problem there? Oh, yes, this should be comma, correct. There we go, right? Okay, 0.2, thank you. So you'll notice that the period 2 forecast not very exciting because it's the weighted average of two 1526s, which is 1526, right? But if you double click, it starts getting updated in later periods, right? 1607 is the weighted average of this and this, right? And then 1626 is the weighted average of this and this, right? And so on. So once you get started, it starts getting updated correctly. All right? And we can calculate the error for this too, based on what we already have. So let's do it. Error ES 0.2. Just going to copy the same formula we already entered. Calculate all the errors. I'm going to copy these summaries, right? And actually, it turns out that the ES.2 did better than any of the MAs so far.
Can you please click once more into the F column?
Yeah, so what I did was I took this formula right here, and I pasted it right here. That's just this formula.
In the F column.
Oh, this one? Yeah, oh. It's easy to make a mistake on this.
And what's the logic about the 0.2, the 30%?
Yeah, so again, you're gonna vary the 0.2 just like you would vary the K to find the one that gives you the best, the lowest forecast.
So if you do 0.5,
Yeah, let me do it. Let me just make sure that everybody's got the formula. Yeah, so I could change this, the way I've got it set up now, I could change this to 0.5, right? And it's gonna update everything. Did it update?
yes.
Yeah.
Yeah. It didn't change this much. I'm surprised. Let me undo. It did change it a little, but not much. What's redo? Control Z? Yeah, 0.5. Undo, Control Y. Yeah, it didn't change it very much. Try 0.8.
So
Oop, 0.8 again. Right, so that's worse. Okay. So that's what I was saying. That's where the solver comes in. Did you get it, Michael?
Yes.
That's where the solver comes in, right? You can say, let me minimize my error and let my alpha go between 0 and 1 as a constraint, right? And it's a nonlinear problem because we're using squared errors, but you can figure it out with the solver. All right, so again, you would do this. So I just want to show you, so you might wonder, well, how do people use this, or do they use it, right? Well, if you go to one of my favorite websites, and I don't know why actually, but I think I started using it a long time ago and I never got off of it, is yahoo.com. And so I'll go to the American version of Yahoo. And it's weird, it's like my go-to place. I mean, maybe it's because I found initially it's easy to navigate. But anyway, I'm gonna go to their finance page. And on their finance page, I'm gonna go pick a stock. One that our students always like is Tesla. So I forgot the code. HAT TS.
LA.
You want the ticker? This one?
Yeah.
LA, I think.
I think is it TSL?
That was TSLA.
I don't think it's A.
Oh.
Is the ticker is the DSLA.
Okay. Sorry, I shouldn't have had the hat. Thank you, Jacob. Apologize. TSLA. So here's Tesla stock, right? It's showing you in time. So you can on this graph, let's see, on this, you can move over from summary to chart, right? And here's an interactive chart of their performance. And on this chart, you can put indicators and you can put moving average indicators. Okay, so we'll do that. we're going to do a 50 period indicator, so that's 50 days. Okay, but you can change that. All right? And you can see 50-day moving average for Tesla stock. So some people are short-term investors, and they believe that you invest based on the momentum up or down rather than on the fundamentals, right? And you may have talked about this in finance, right? Where, you know, most finance theorists believe, I think, that you should look at the fundamentals of the company, the ratios, all these kinds of things, and you invest on that. Hold for the long term, because you can't guess whether the stock's going to go up or down. You buy good companies and hold on to them. What this says is you're buying on momentum. So if your moving average cuts through your stock price this way, right? If your moving average moves above your stock price is moving down, it's time to sell the stock. And if your moving average moves through the stock price when it's going up, it's time to buy the stock, right? So these are buy and sell signals. And this type of analysis, by the way, is called technical analysis. You're essentially evaluating it based on market movements or momentum or sentiment, if you will, rather than on fundamentals. Now it's tricky, right? Because you see it went through twice right there, and why did I pick 50 periods? Why not 20 or why not 10, right? And so there's something to this. And I think for a long time, I don't know, I'm not a finance professor, but for a long time, technical analysis was really, by scientists, really thought it was a bunch of BS, a bunch of hocus pocus. But now there's some evidence that some people know how to do this. And so I think what they would say is you filter your companies down on their fundamentals, and then you buy based on their momentum to some degree. Sort of a combination of techniques that people use. But anyway, this is one example of where moving averages actually get used, right? Where you can see that if the moving average moves through the stock price is probably heading in the wrong direction. But if it moves through the stock price, if it cuts through, stock price goes above the moving average, time to buy. Questions? Okay, just so you can see, in that same chapter, give me 1 second here, I'll just show you one example. I didn't put it up there, but I should have. In day 1, part 2, day 8, part 1, I'll put a second file up in the watercraft example, which is the last example. Actually, I built the quiz today off of this data, but I changed it a little bit. Let's see here. Down here. Let's get the watercraft done. All right. So in this pretty gnarly looking spreadsheet we're going to look at here, let's get it open. Reload this, right? And I'll give you all the finished ones in case you're interested. Do I have a graph here somewhere? Yeah, so I have a graph here, right? This is the sales of watercraft, right? Which are, you know, probably like air conditioners or have a seasonal effect. There's also obviously a trend in this data, right? And once you learn how to do moving average and exponential smoothing, you can build on these models. There's a famous model called the Holtz model, which accounts not only for these sort of idiosyncratic business cycles, but it also incorporates trend. And there's also a model called the Holt-Winter model, which is even more complicated, has 3 parameters, alpha, beta, and gamma, that also goes for seasonality, right? And so what I've done in this spreadsheet is I've built the Holt-Winter model with additive seasonal effects. There's a Holt-Winter model with multiplicative seasonal effects. I'm not going to explain what that difference is. And also I've done a regression model, it looks like I did it twice. I'm not sure why. Anyway, all those sort of models put together, right, sort of give this level of performance. I can't remember which one's the best, but you can see that with more sophisticated versions of these moving average and exponential smoothing models that account for seasonality and trend, you can get pretty good fit, even on some fairly complex data. Now, of course, this is a baby school example, right? There's the noise is sort of worked out, but this kind of builds on this whole concept of exponential smoothing and moving average. So usually I do a little module on this in class. It kind of drives the students crazy because the formulas are, as you guys just discovered, they're not that fun to enter. But anyway, this stuff does get widely used, and I think this example, you know, looking at Tesla stock shows that it does. Boy, it looks like Tesla stock's kind of leveled out a little bit there. It was, if you go back a couple years or 5 years, right, it's a different story, right? But recently, I think their operations are starting to hurt them, right? They've got all these orders for cars and they can't deliver them, so.
The operational management is not the best.
Yeah, evidently.
Can you tell us just really briefly something about alpha, beta, gamma?
Yeah, so if you look here on this example, the three components are, we just were working with exponential smoothing, and actually I've set this up so that you can optimize these numbers. There's also a beta. The beta is the weight between, the beta is the weight, is the trend weight. So it's the weight between the current forecast, the current trend level, and the trend level in the past. And what a value of 1 says is, just look at the current trend, don't look at the past trend.
So is the variance between current trend and trend above?
Yeah, this is sort of the idiosyncratic error that we were looking at before. This is the alpha, and then the gamma is the seasonal thing. So how is the seasonal index this season compared to the same season last year?
Like year to year?
Yeah, year and year. Yeah, and so if you look at these formulas, these formulas are a little tricky. Well, let's see. It's because, let's do this. Let's go 0.5. Oops, 0, comma 5, comma 5, comma 5. So if you look at, right? Oh, those are starting conditions, sorry. So there's the exponential smoothing forecast that we just had. If you look over here, it's a weighted average of a couple things. And if you look over here, it's also a weighted average of a couple things. So without going into the details, they're basically all weighted averages, right? Of the last, I guess you call it idiosyncratic error, ET, the weighted average of the trends, how the trend's doing now and before, and the weighted average of what was it like last quarter 1, what's it like this quarter 1, so.
You could also use different gammas, right?
Yes, you can.
I don't mean for the whole equation. I mean within a single equation.
Yeah, you could update these weights every period. I think the thing is you're trying to get the sum model that you can then use in the future to forecast forward, right? And so all this fitting business is about forecasting forward. Again, be honest with you, lately when I teach this stuff, I find out that regression works better than the other methods most of the time. So I'm kind of a regression guy anyway, so you kind of got what you need to know with regression. You know about time, you know about indicators, you put it all together, at least you tried on the quiz, right? So you got an idea of how it works. But
I wonder if you can optimize by trying to find the optimal gamma per period.
yeah, so you bring up an interesting issue. If you have a different gamma for every period, you now have a lot of gammas, right? If you have a lot of parameters, you need a lot of data. I don't know if you remember back to statistics, but we kind of have a rule of thumb, you need 4 times the amount of data you have parameters, right? Well, one of the things that happens in these really complicated big analytics models like neural networks is there's a lot of parameters in those models. So you need a huge data set, basically, to make them work well. But that's the way the world is moving. So data sets are getting huge, and people are building these super complicated models. There's a little bit of fear, I think, on some academics' part of the models are so complicated, people don't really know what they're doing, right? And so, we're pushing the boundary. Okay, it's 12:34. I said I would get you done at 12:30. It's lunchtime. When we come back, we'll start on decision analysis. Totally new topic, totally new thing. And like I said, we'll cover that this afternoon. We'll try to be nice and awake for our guests and hospitable, hopefully, somewhat. And help out the program a little.